Hey everybody, just quick heads up. This video is a lot different than what I normally do, and to give you the full explanation on it, in my speech class, I did this informative speech on this video that you're gonna watch, and these people they wanted to know more, but I zoomed through the information because I was on a time limit for the speech. So I didn't exactly get everything out that I wanted to get out. So this video is pretty much for the folks out there that wanted to see the rest of my speech in full without, so much as a time limit onto that crap. Because I can't crunch anything down to save my life. So just a heads up before we start. In the description down below, if you hit that little arrow down below, I will have timestamps to each of the different sections. If you want to skip over a section, that's completely fine. I understand that, maybe some of you aren't interested in, like, the plants, for example, or talking about a particular dinosaur for at least, like, 5 to 10 minutes. That's totally understandable, and I get it. So all I'm just saying is I hope you guys enjoyed this. It's kind of an honor to redo my speech all over again, and that you guys are actually interested. And I'm talking to my classmates about this. But to everybody else who's already on this channel, I mean, you already know what's about to go down. Imagine the Earth 66 million years ago. And now you're probably telling me, why are we even bothering to talk about this? Well, let's put it in this. Scientists look back into the past to figure out where we came from. Or at least they look at it from an evolutionary point of view. Like, how did life come to be, per se? The amount of species that came from these tragic events as well, that they're still around today. So this was before the asteroid impact hit the Earth. And we're going to look back and we're going to look at what the environment was, the types of plants that were there that are still around to this day, the dinosaurs that were there and are sadly now extinct, and the other types of animals that coexisted with them. And some of them are still around. I think I have one exception. He's unfortunately extinct because I'll get to that later. So let's dive right into the past. Now, the footage and the photos that you're seeing right now on screen, they come from Keelio National Park. I probably butchered that name. I apologize, guys. It's a national park in Chile, and it's the best representation of what life was like 66 million years ago in Montana. There was ash fields all over the place, so it was very a volcanic environment. There was no grass anywhere. Grass didn't evolve yet until like 30 or 35 million years ago. The areas surrounding these ash fields were covered in monkey puzzle, tree forests, and swampy areas. So the environment was still very tropical, but at this point in time, life was starting to, let's say, die out. Life was basically choking itself at this point in Earth's history. So the different types of plants that are still around even to this day, funny enough, both cypress trees are still around, and they're still always in swampy areas. Like you go down to Louisiana Bayou or Florida Everglades, and you'll see these things all the time. These trees have a unique ability, and this is why they've lived for so long, is the fact that they can root in places that are underwater, so to speak. They can actually put themselves underwater and stay there and be totally fine. Palmettos, I think is what this plant is called. These plants I usually see all the time when I go to Florida, but you may see them when you go to like coastal regions, like to a beach or to California. You'll see these a lot. These plants, they come in two different varieties, and they're very much like fern-like in a way, but come in two forms. There's the bushy form that you kind of see all the time, and then they have this interesting palm-like form that's what you see lining up on the streets when you're going down in the car. So they're not technically palms, if you will, but they are a type of plant that can look like a palm, but it's not a true palm. Ferns are all over the place. From where I've been growing up, and from probably where most of you have grown up, you probably know what a fern is. You probably know what it looks like. Ferns have been around for like ages, considering that they're low-lying and they need a lot of sources of water. And usually, the first set of vegetation that has ever come to this earth needs a ton of water to reproduce in a way. So the same thing with the horsetails too. They've been around since the very beginning when the first plants have started coming up on land. So they do the exact same thing. They need to be near water in order for them to reproduce. So this is why you kind of see them a lot in like marshy or swampy kind of areas around sources of water. Then we have two other trees, which I'm actually recording this outside. So the first one being dawn redwoods. These are like miniature giant sequoias that you see in California. And the interesting about this conifer in particular is that, considering that I'm in Delval and they have them outside, the interesting thing is they actually shed their leaves, which, to be honest, is really cool. I never thought a coniferous plant could be able to do that, but this is one of the first plants that I've seen that could actually like shed and then over cold periods or over the winter season are completely bare. They have no leaves on them whatsoever. And then ginkgos, everybody's tree that they all love, going in between Mandel and Seagull. So these trees are very unique. They have their U-like shape leaf to them, and they produce these seeds. And this is the reason why everybody loves them, and I'm saying this with a ton of sarcasm, is the fact that their seeds, if you break the seed, it actually stinks pretty bad. Which, in Asian medicine, it's actually used as like an herbal way of like curing. I don't recall what type of curing that could be, but ginkgo trees are like very rare and they're used for medicinal purposes in Asian cultures. That's all I really need to know. That's all I know, and that's all you really need to know to be certain. If you want to look that up, I go ahead and do so, but I'm not going to go into depth like crazy with it. Then you have the two ancient ones, and you've kind of seen through the video one of these plants is the monkey puzzle. Now, monkey puzzles have been around, like the other plant I'm going to talk about, since the Jurassic period, over 150 million years. And they grew to massive sizes. I mean, the one that I'm showing you in the photo here is like tiny in comparison to the ones that are over in that national park. But these conifers, if you will, are unique in the fact that they're spiny all over the place. The trunk of the tree and even the leaves are like covered in like these scale-like spikes. And it's kind of interesting considering the fact that nothing, at least at this point in time, will eat them. So they grow to these massive sizes because nobody wants to eat them. They're too spiky. And then the other plant being cycads, which have also been around since the Jurassic period. and they look like a mix between a fern and a palmetto plant. They do very much look like a mix between the two. But the key difference here is their cone-like structure on the top of the plant, and that's used for reproduction. So it looks like a fern, but it acts like a gymnosperm, which is kind of interesting. I never thought I could imagine that. So that's all the plants around this time period. For the most part, these are all the plants. Then to the dinosaurs themselves, and this is why I have the timestamps in the description. So I'm just going to summarize these up to the best of my ability for right now, and then I will move on to go to the individual ones. So you had multiple different types of dinosaurs that lived within the area. You had dinosaurs with club-like tails and armor all over them. You had dinosaurs that could butt heads and use them for breeding purposes. You had very much like running dinosaurs, like ostrich-like dinos. You had dinosaurs that acted very much like modern rhinos of today. Considering their looks, I mean, that's besides my point. You had a lot of giant duck-like dinosaurs. And then you obviously have the Tyrannosaurids, and everybody and their brother knows about the Tyrannosaurids. And like I said, I'm going to say this one more time. You guys can skip all the way towards the end, and I'll probably talk about the fauna, the other fauna there, or the other animals that existed. But for right now, I'm going to go through each of the dinosaurs one by one. So if you want to skip to that time frame, it should be down there. It doesn't matter to me. Yeah, I'm all cool with that. So let's actually kick off with the first dinosaur set. It's classified as an Ankylosaurid, and obviously, given the name, Ankylosaurus is kind of where it got its name from. And unfortunately, Ankylosaurus is the last of its kind. I feel so bad for it. But at the same time, you look at the animal and you're like, yeah, that definitely classifies it as Ankylosaurids. And there were other earlier versions of Ankylosaurus out there, but this is the last of them. This will be the last of their kind. But this dinosaur is already unique in itself, that it's got armor plating up on the top, where it's all spiky and whatnot, so it helps it protect from predators. It's so bony all around that even its eyelids are made out of bone. They're not actually like fleshy. They're actually made out of bone, so it's really kind of cool. But the unique feature about this herbivore is its club-like tail. And I'm not gonna go into the physics or the PSI of how much damage that tail can do. But the tail is so powerful that it could shatter the bones of a T-Rex in one hit. All it needs to do is swing that tail once and hit it, and then the T-Rex is done. So this herbivore is interesting in the fact that it'll actually break bones if it actually lands a blow. It's not very bright, but it does know how to hit, and it will kill a fully grown T-Rex in one shot. It's actually pretty damn dangerous as a herbivore, but if you're not like really being aggressive with it, then it's actually kind of just, gentle. It just deals with everybody. It's just the one time where it feels threatened, that's when you need to stay away from this dinosaur. Moving on to the Ornithmids. So these are more of the running sort of dinosaurs, and there were two different species of them, and it's kind of hard for me to describe the differences between these two, considering the fact that they look pretty much the same. So we're going to start off with the way that they're different, and it's by size. So for the first dinosaur, it's going to be Struthiomimus. It's actually the larger of the two, and there's really nothing much you could say about Struthiomimus and Ornithmimus other than, the size differences, because they pretty much behave the same way. They are like in flocks or in like little herds so that they can keep an eye on each other. They are pretty much like the ostriches of the dinosaur world. It's very much like Gallimimus, but it's the North American version of Gallimimus. Um, and these prey items are so quick that even T-Rex doesn't really want to deal with them that much, because T-Rex can't run as fast as these guys, and this is why they're like two different species of them in the same area. It's because nobody can catch up to them to eat them. They do hang around with other types of herbivores, such as Triceratops and Edmontosaurus, which I'll talk about them later, just for the added protection. But on their own, they are pretty quick enough to like invade predators, and they're very much duck-like in the way that they eat. So they've looked at skulls for both species, and they've noticed they don't have any teeth. So instead, what they do is they would eat up watery plants. They're pretty much like ducks. So take a duck and an ostrich, and boom, you get these two dinosaurs here. That's all I'm going to really describe about the Ornithmids. And now to the Pachycephalosaurids. Now, these are the guys that all three species can easily do this, and they do it for reproductive purposes, is they have these dome-like heads on the top. And so they behave pretty much exactly what you would expect from a bighorn sheep or a musk ox. And they would use those domes, those bony domes, if you will, to bash into each other, like the horns on a ram or the horns on a musk ox. That's pretty much what Pachycephalosaurids are these dome-like, sheep, pretty much. That's a basic summary of what they are. And then to the three individual species themselves. So, the first species I'm going to describe is actually named after character from the Harry Potter series. So, any of you are Harry Potter fans? I'm hearing some voices there. Yep, okay. So this dinosaur is probably for you. He's named after Drake from the Harry Potter series, so it's called the Dracorex. And this dinosaur, I mean, they're all herbivores, but seriously, the skull on this dinosaur looks exactly like what the name suggests. It looks like a dragon's head. But it's still a pretty small herbivorous dinosaur. It won't eat anybody. It's just the skull looks pretty funky off it. Next, we go to Stygimoloch. Stygimoloch is another Pachycephalosaurid that lived around this time. And the interesting thing about that, and it kind of looks similar to the next one I'm going to talk about, but instead it's got spikes still on the back of its head. So it still has the normal dome, but it's got spikes all up in the back. And the name Stygimoloch roughly translates to demon from the river Styx, which I don't think that's very accurate to name it like that, but hey, what do you want to do? What are you going to do? Which leads up to Pachycephalosaurus itself, the one who named the entire family. And this dinosaur, not much special. He's nothing too special. He is the largest out of all the three, and he kind of, let's per se put it, normal, the most normal looking out of all three of them. And the interesting thing about Pachycephalosaurus is that there is a theory going around stating that Dracorex and Stygimoloch are the juvenile versions of Pachycephalosaurus, and that Pachycephalosaurus is the adult version of those two species. That has been somewhat confirmed. People are still debating over it, but it is a likely possibility because you look at the individual skulls and you can see that there is a slight difference as you're going up. So it would start with Dracorex, not really having a dome with spikes on the back of its head, then to Stygimoloch, where the dome is fully or almost fully developed, but it's still got like the spiky ridges on the back of its neck. And then you evolve to Pachycephalosaurus, where it has this fully formed dome, and then the spikes on its back of its neck are like stubs now. They're not really, the spikes aren't really used anymore off this dinosaur. So it is a believable theory. It's not been 100% confirmed or 100% denied, but it is an interesting idea that scientists are debating over if this is a legit theory. Moving on to Hadrosaurs. Now, thankfully, the two species here are different. We'll start off with the one that has been sort of changed now, very recently, since 2013. Oh boy. Well, let's put it at this. Edmontosaurus is the largest hadrosaur in North America. Sitatung or Shangtungosaurus in Asia is the biggest hadrosaur ever, but considering that this is Montana 66 million years ago and that thing's now long gone, I think I could safely say that Edmontosaurus is indeed the biggest hadrosaur on North America. The recent discovery I mentioned is the fact that scientists, after looking at the death pose of this dinosaur, have noticed something. Is that it actually has a U-shaped like crest on the top of its head. It's not bald or anything. It's actually got a crest. Now, scientists still don't know what that means or like what the purpose of the crest could be. It could be like very much like other hadrosaurs have their crest. It's to make, certain vocalizations and to let other members of the herd know, dangers afoot, or it could be used as a mating call, if you will. So those are like main functions of Edmontosaurus, but they're still not 100% sure on what it could be used for. By the way, Edmontosaurus is T-Rex's favorite meal. So if he went out to a restaurant and he looked through the menu, he'd be like, I'll take the Edmontosaurus, medium rare. So, yeah, so other than that, Edmontosaurus is by far the biggest, but is T-Rex's favorite food, so let's put it at that. But there was another species of hadrosaur there called Anagnatotitan, which some scientists have been debating on whether or not Anagnatotitan and Edmontosaurus are pretty much the same. But we can confirm that that theory is not true, considering the fact that Anagnatotitan does not have a crest and is a lot smaller, is smaller than Edmontosaurus. They lived in the same area, but kind of like Struthiomimus and Ornithmids, it's a size difference. That's the key. And, the crest, the Anagnatotitan does not have a crest. And this hadrosaur actually stays more closer to, watery areas, whereas Edmontosaurus would diverge off from the swamp. So Anagnatotitan is more specifically stuck to its swampy area because of its diet. And it's very much like Struthiomimus and Ornithmids, where, on the flip end, it does have teeth, but it would rather chew up watery plants as to other types of vegetation. Next is my favorite, the Ceratopsids. So pretty much the rhinos of the dino world, if you would like to call that. And obviously, we know what Triceratops is. Everybody and their brother knows what Triceratops is. Heck, T-Rex and Triceratops have been long-living rivals since Triceratops has been discovered. It's been that crazy. So, Triceratops literally needs no introduction. It is one of the most famous herbivores around this time, along with T-Rex. And it was thought to be believed that, Triceratops was the main meal of T-Rex. Nah, that title goes to Edmontosaurus easily. And there were differences for Triceratops, like, sexual dimorphism, where the males would be a lot bigger, differently colored, longer horns, and the females are, the opposite of that. So they did kind of have this sexual dimorphism with them, with the species. And which leads me to this theory, which, a lot of people have heard. So, Torosaurus, if you have not heard from the Discovery Channel recently, and this was probably 2015, 2016 when they told everybody, that a theory came up stating that Torosaurus is the adult version of Triceratops. It's very much like the Pachycephalosaurids, where it was Dracorex, Stygimoloch are the adult versions of, or the baby versions of Pachycephalosaurus. So it's the same thing here. But now, very recently, and I'm very thankful for it, this theory has been denied. The theory's been denied due to the shape of the frills. Due to frill shape. Torosaurus has this more square or rectangular shape to its skull, whereas Triceratops, it has a more round or oval-like shape to it. But these animals are pretty much the same, same size. It's just the frill is the big difference, and the fact that Torosaurus had eye spots on its frill, so it would deter predators, but also scare rivals during breeding season. Which leads me to the one dinosaur that I'm literally not going to explain, at all. I'm so serious. I'm skipping over T-Rex, because everybody and their mother knows what T-Rex is, has seen a bunch of documentaries on it. I'm not even going to bother with T-Rex on this. But I will bother on another Tyrannosaurid that was around T-Rex at the time. And you're probably saying, wait, what? There's another Tyrannosaurid? And I'm like, yes. And then I'm going to ask you this. What if I told you that this other Tyrannosaurid, even though it's smaller than T-Rex, actually actively hunts juvenile T-Rexes? Sounds pretty ballsy of a dino, huh? And that's exactly what Nanotyrannus is. And again, there is also another theory, which I'll explain in a second here. But Nanotyrannus, pretty much this Tyrannosaurid, if you will, actively hunts and kills juvenile T-Rexes for competition. It's to get rid of T-Rex as a competitor in its environment. It's much more of a speedy Tyrannosaurid, so it goes into T-Rex nests, kills the babies very quickly, and then bolts off. And its diet also consists of young Tyrannosaurids as well. Because sometimes after it kills an entire nest, it will actually go and actively eat the youngsters in there. So it's really kind of a cool dinosaur, but at the same time, scientists once again, very much like Triceratops and Dracorex and Stygimoloch, they think Nanotyrannus is the baby version of T-Rex. Scientists took they rethought about it, and they went, you know what? Nah, that doesn't work. Because, again, it's based off skull structure. T-Rex's skull is very much, squared in, if you will. It's very much more of a box shape. Whereas you look at the skull of a Nanotyrannus and it's more elongated. It has a much longer snout. Now that could be because when it gets to an adult, it just squishes its face in, and there you go, you have the jaws of T-Rex. But I don't think so. I think it's what it is, like this narrow, elongated skull, so it can reach out, grab the young, kill them very quickly, and then bolt the hell out. Now, they could have also hunted Struthiomimus and Ornithmimus a lot easier than T-Rex, but T-Rex could pretty much eat anybody if he really tried. I mean, except Ankylosaurus. Ankylosaurus is just ridiculously strong. So that pretty much concludes all the dinosaurs in this particular area. Which brings me to the other types of fauna that existed. So, along with all those dinosaur species, which you've probably heard me ramble on for about 20 minutes or so, maybe longer than that, there are other types of animals that lived in that area. Freshwater stingrays would be one of them. They now exist in South America, but these stingrays were like everywhere, along with long-toothed sawfish, which is a species of shark. Really, it's an offshoot of the shark family that lived around North America around this time, but due to the mass extinction, this type of stingray moved to South America, and the long-toothed sawfish was moved to more tropical environments. It's still a freshwater sawfish, but it decided to move into much more warmer environments. These next two fishes actually are a part of the state of PA. We have these fishes. The bowfin fish, or otherwise you could call it the dogfin fish, or the dogfish, and spotted gar. Now, these species were a lot bigger than they are now, and that's probably because of overfishing as well. That's another huge issue that we have towards these two. But these two species were in Montana around this time frame. Bowfish is unique due to its two fin-like structures on the top and the bottom. And the gar, obviously, is already unique in the fact that it's a killer fish that looks like a pin. I mean, literally, look at it. It looks like an elongated pin, and that's how it hunts. It just dives straight in like a missile. And then obviously everybody and their brother knows of the crocodiles. And there were giant crocodiles back then, but they at this point have now become extinct due to their size, because it took too much energy to feed a massive, like, 40 or 50 foot body for a croc. Then you have lizards. The Tuatarian's pretty interesting in its own right because it's a lizard that is now only found in New Zealand, but it could have been found everywhere. It was found everywhere when the dinosaurs had their last moments of life on this earth. And what's interesting about this type of lizard is it's got a hidden third eye. Now, you don't see it on the actual animal itself. I mean, goodness gracious. That would be creepy. But it does have a third eye. It's hidden underneath the layer of skin it has. But it's not an actual eye for, like, seeing. It's more to detect fluctuations of light so that it can tell, what time of day it is or what type of season the sun is in. So if it's winter, then it knows there's a shorter sunlight period, which is actually honestly still pretty cool. But these things are slowly starting to die out as well. And yeah, I'm not going to get into that. Whip-tailed lizards. Now, these are everywhere in North America. You can find these in different regions and whatnot. But the interesting part about these lizards is the way they can self-baby make. And Oh boy, this is gonna be hard for me to describe without getting into too many of the specifics, but let's just say this. Many reptiles can actually, like a lot of female reptiles, can actually self baby make and make identical clones of themselves through asexual reproduction. They can do that with an unfertilized egg. The way this whip-tailed lizard does it is it will actually attach to another female, do it, but then the eggs are still identical clones to the mother. So it's really just a unique lizard in the fact that it can actually reproduce on its own and have identical female offspring to it. That is unfertile. But they can still mate regularly. It's just if, push comes to shove and there's no males around, that's exactly what they'll do. The Chinese crocodile lizard is another interesting looking lizard because it looks exactly like a crocodile. It can swim like a crocodile almost. But it's a lizard. And they are only found in China as of today. But they used to be everywhere around this time. It was another one of those unique looking lizards. It's like the Tuatarian, but it doesn't have that super secret eye. It's just a lizard that can honestly swim from any other types of dangers. Then the snakes. So actually, this is around the time snakes evolved, which is curious because, you would have thought like, oh hey, snakes could have been around since the Jurassic period. Oh cool. No, they started actually evolving around this time, which is pretty damn cool. And the first set of snakes were not venomous. They were more constrictors. So the boa constrictor was one of the first snakes to ever evolve. And what these snakes do is they hunt mammals. So they would hunt proto-mammals, constrict them by wrapping themselves around the animal, suffocating it, and then eating it whole. And they could find these other types of mammals through heat signatures of the animals. It's kind of like seeing the world in UV light. So they can see all different types of heat measures within the environment, which is honestly really cool to see. But these types of snakes, they're no longer in North America, obviously. They're all more closer to South America and parts of Africa and somewhat. But snakes started evolving around this time, so it's still pretty damn cool that, lizards eventually said, we're going to diverge into these types of things. So it's really interesting. And then obviously you have bees and moths that evolved around this time because this is when the first angiosperms or flowering plants started to evolve. So they evolved right towards the end of the dinosaurs, which is kind of funny if you think about it. But there were multiple different species of prehistoric bees, prehistoric butterflies, and moths all around. And again, they do the same thing that they do nowadays, is pollinate the plant so that the plant can sexually reproduce. And then obviously you've also had birds starting to evolve. So birds actually now are in the scene, and there are no pterosaurs to be around this area, so to speak. And hodisons are one of the first, and I mean their calls are bizarre on their own, and the look of these things is really it screams ancient, like the Tuatarian. It screams ancient. It screams an ancient bird. So these birds are now located in places like Chile and Peru, so still in South America. But they once did live here in North America, but they died off because of the mass extinction that happened. And then you started getting the Proto-Mammals, or not like the true mammals. And all these mammals are like extinct, unfortunately, due to the mass extinction and the fact that larger mammals evolved after this event. And one of the first starting mammals is Didelphodon. And Didelphodon, to be fair, I mean, I will agree with the audience on it, does look exactly like a Tasmanian devil. And it's a marsupial, so it's very much looks like a Tasmanian devil. But if you look at it further through an evolutionary lineage, it's actually the ancestor to opossums. Funny story, isn't it? Like, possums came from a thing that looked like a Tasmanian devil. And these types of mammals obviously survived on basically eating dinosaur eggs, lizards, pretty much anything that was low to the ground, they would eat. They would honestly try to eat. It's a damn shame, but unfortunately, Didelphodon is now extinct, like all the other mammals that existed around the time of the dinosaurs. But in the end, let's look at this. All of these other types of mammals or other types of animals and plants came around this time and survived the mass extinction. Why is that? We're not 100% sure. It could be due to size and because watery environments, like if you're a creature that lived in a watery environment, you can escape from things like that. But to giant things like the dinosaurs, they were gone. They could not survive the changes in the environment. I guess you could say we're lucky to have these species, but at the same time, these species are also going. They're dying out because of us. And it's a sad thing, and I don't want to bring up conservation in this video at all, because this is more based on what was back in the day, and some of the animals and plants that are around our time now that still exist. But it has to be that, because overhunting, overfishing, a lot of that is a key factor as to why these things are going. And I would usually say stop doing that, but that's not very effective to say that at the very least. I mean, what could you do? What honestly could you do? That's really the question that you should be asking, is what can we do to help? And to be fair, this was honestly all these animals, all of them. If we didn't look back into the past, we would have no idea where they came from, why they still exist. It's still a really cool thing to see it all come full circle, even when the dinosaurs are gone. Other creatures, other organisms can survive a massive extinction such as this. So, I hope at the end of the day, everybody knows that these animals did survive, unlike the dinosaurs. And that what you take from this so-called video is we need to look more into the past and see what evolution has done. And if we understand what evolution has gone through to get all the way to us, then we can start understanding the other creatures that are around us to this day. And this pretty much concludes the video. So I hope you guys really did enjoy it. You can leave a comment down below. Let me know if you want me to do more of these or not. If you thought it was actually interesting. You can like the video and subscribe to the channel for more additional stuff such as this. And until next time, guys, see ya!